Hi, this is Sung and I'm the Principal and Director of Sky Academy. And in the last episode what we were looking at was the discriminant, and we looked at how the discriminant affects a parabola. Right? In this episode what I want to do is look at some specific questions that might be asked on the topic and we'll look at an example that I have on the board, which is find the discriminant of the following and determine whether the expression is positive definite, negative definite, or indefinite. Now, if you need it, I've left the notes up from the last episode up on the board, so please refer to that as we go through it if you need to. But let's have a look at the discriminant of each one of these and determine whether they're positive, negative, definite, or indefinite. Okay, so let's have a look at the discriminant. The discriminant, of course, is b squared minus 4ac. So for this particular example, b squared minus 4ac is equal to 7 squared minus 4 times 1 times negative 3, which is 49 plus 12, which is, what is that, 61, yes, which means that the discriminant is positive. It's greater than 0. You have two distinct roots, which means part of your graph will be below the x-axis, part of it will be above. Therefore, it's not definitely above or below, it's indefinite. And that's the answer for that one. This one, alright, the discriminant b squared minus 4ac is actually equal to 7 squared minus 4 outside of 2, negative 2 times negative 8. Overall, you got 1, 2, 3 minus signs, which means the overall value would be negative. 4 times 2 is 8, 64. 7 squared is 49. The discriminant will be negative 15, which means that there are no real roots. The parabola will be definite. Whether it's going to be definite positive or negative will depend on whether the curve is concave up or concave down. In this particular case, minus 2 is our leading coefficient, which means that the parabola would be concave down, and for the fact that there's no real roots, the whole parabola will be below the x-axis, which means it'll be negative definite. Alright. And for the last one, b squared minus 4ac, b squared would be 5 squared minus 4 lots of 1 by 7, which is 25 minus 28, which leaves you with negative 3. So again, you have no real roots. The whole parabola would be definite, but whether it's above or below will depend on the leading coefficient. Yes, the leading coefficient 1 is positive, so it would be positive definite. I'm just going to rub the board out now and come up with a second typical sort of a question that you might be asked. So I'll just press pause and I'll see you shortly. Thank you. Well, I'm back now, and I've written up another example on the board and we'll go through that. The example is find the values of k where x squared plus k minus 2x plus 4 equals 0 has 1 root, 2 roots, or no roots. Okay, and obviously the question is assuming that the roots are going to be real. Okay, so 1 real root, 2 roots, and no roots. When will an equation have 1 root? It's when the discriminant equals to 0. So let's find the discriminant of that. So the discriminant is equal to b squared minus 4ac, which is basically k minus 2 squared minus 4, a is 1, c is 4, let's work that out. So you've got k squared minus 4k plus 4, and then minus 4ac is minus 16. So your discriminant is equal to k squared minus 4k minus 12. And when will that be equal to 0? Alright, so one real root, k squared minus 4k minus 12 equal to 0. Well, you use the cross method, and 6 and 2 make 12. The difference of them is 4, so that's a really good start. 6 and 2, one of them is going to be negative because it's minus 12, and it would be the bigger number that's negative because you got minus 4. So basically you've got k minus 6 and k plus 2 equals to 0. So the answer to this question, for what values of k will the discriminant be equal to 0, or will there be one root when k equals to positive 6 or negative 2? Does that make sense? The next question, when will there be two real roots? Well, we want two real roots when the discriminant is greater than 0. So we want when k minus 6, k plus 2 is going to be greater than 0. And the reason why I jump straight to that is we know that that factorized is going to be equal to k minus 6 and k plus 2, and that form is more useful than that form, so we jump straight to that. Alright, so when is k minus 6 and k plus 2, when is k minus 6 times k plus 2 going to be greater than 0? Well, that's going to be a concave up curve. So you've got minus 2 here and positive 6. And when will that be greater than 0? It'll be greater than 0 for this region here. So the answer will be x is less than minus 2, or, remember we use the word or, not and, x is greater than 6. Okay, got that? When will when will this have no real roots? It's when this, the discriminant, is less than 0, which will be in this region. So it'll be from minus 2 to 6. So the answer is when k, whoops, that shouldn't be x, that should be k. I'm just so used to writing x. So when k is less than negative 2, it's less than 6 and greater than negative 2. Okay. So that is another typical sort of example that you'll get on the discriminant. Okay, so thank you very much for watching. I'll see you on the next video.